I appear to be sharing a screen. Yeah. Okay, cool. Looks like we're good to go. So, so we'll go through. We'll have a look at some of the details, and then we'll either go into a case study, or we can jump onto the tool itself, see how much time we have. There's a lot of content here, so I'm going to just expect you to keep up. I'm not going to be explaining things like U values or solar heat gain coefficients. This is a bit of preaching to the converted. Before we kick off, just a couple of acknowledgements. With the ABCB, I was given a contract to undertake this work. So I'm not involved with the ABCB other than that contract that is now finishing up. And thank you to IBIPSA, sorry, I always get that wrong, never get it right, for inviting me here today. And also, Jessica Hogg, this is my friend and partner in crime in this particular episode of Crime. She's here at the front, and she is a co-author of the tool. She had an equal part to play in this. So I won't go on about Fabric First. It's a company I started up about a year ago. Do stuff in the building physics space, work in the passive house space, looking at diagnostics, looking at all sorts of things to do with the building envelope. That's it. No sales pitch. So where it all starts is with an awesome image, right? So this is a to be or not to be sort of reference. It's about the fact that many of us in the industry have been asking questions about the to be or not to be. Is it going to come in? How is it going to come in? How are changes going to manifest themselves when it comes to big visions and the updates to the NCC? And we've all been asking questions. I've been asking quite a few of them, throw up a few blogs here and there. When I get time, when I'm jumping on a flight or something, I'll focus on one thing. When I get a project that is just a problem, I'll probably reorchestrate that into a blog post. And I found that this process for myself has been good because it's allowed me to understand, I guess, the industry and allowed me to sort of get involved with industry players. Now, back in 2016, Jess and myself and some other people were involved in a collective. And it was a really cool experience because all these guys here, we all got together when the NCC proposed some 2016 changes, and the changes were fairly horrible, to be honest. There were loopholes, there was failures to really justify what was being put forward and promote better buildings. And there was one other aspect, was the fact that there was the perceived lack of, I guess, value to companies was unified, and we all felt that we were taking a step backwards. So this random group of people, they literally got together in 1 week, and we said, okay, let's sit down. And we had a hell of a lot of experience. We knew what we were talking about, and we put out a feedback to the NCC or to the ABCB in regards to the NCC 2016. That feedback was taken on, and of course we went through then a process of a public draft. Again, an opportunity to provide more feedback. I'm sure many of you were involved. Many who put in some comments to that. A few of us. Okay, good. And then as we went through, we got to the preview, which was, I guess, thrown in. There was a bit of flip-flopping in the ACT in terms of how they perceived their position. But we are now pretty much all on the same page in terms of states and territories in regards to NCC 2019. Of course, there is a couple of dates to mention. Obviously, we have May this year in terms of the general provision section J pushed back until next year. How many of you have downloaded this document, or not the preview, but the final version? Yeah. Have you spent much time on it? No. 5 hours, 10 hours, 20 hours. Okay, just seeing how much focus there was. So now, in terms of the work that had been done preceding the work Jess and I were doing, there was certainly some predictions. I think you could probably predict the outcome of that a bit better than what you can predict the outcome of the provisions coming forward, because there are very high-level aspirations, and they're great. Looking at percentage energy savings as a result of the proposed changes from 2016 to 2019, big numbers. You'd have to ask yourself, though, if there were bullets out there that were so efficient that we would have been using them already, because to talk to the I guess the benefit cost ratios of trying to deliver cost neutral changes is very I'm very skeptical about where these numbers came from, and I believe that there are major cost uplifts because we're improving buildings. We've got to improve buildings through investing money in them. It's as simple as that. We don't improve buildings by finding some little tweak that energy modelers haven't found for the last 10 years. So what we're going to be looking at today is section J, energy efficiency, volume 1. So as we fly through this, how many of you are familiar with JP1? Have you had a look at this? There are some changes there, some stuff there. So this is the performance requirement, right? This is your performance solution, DTS verification. This is what you need to hit, okay? So some things make absolute sense. Some things are introductions. Some things potentially make a little less sense. Maybe others can explain them to me. Function and use of a building, yeah, absolutely. And energy use should be appropriate for that function and use. Human comfort, I think there's a great introduction. How it's handled is interesting from a PMV point of view, but it's a good introduction to see that human comfort is a priority alongside energy efficiency. Anyone that's across the performance space will know that human comfort generates energy efficiency, because you put that human comfort first, you'll get a great outcome in terms of your design. Solar radiation, nothing new there. It's always been a component. Energy sources, so renewable energy. JV3 modeling now has I guess a verified inclusion of how renewable energy can be treated. As long as it's produced on site, it can be used on site. You're not buying in renewables. Air leakage, that was in 2016 in the same type of language, but we do have the introduction of a verification pathway now, verification 4, I believe it is, and that introduces an opportunity to really just meet the requirement of E, okay? It's just E, it's nothing else, it's just E. As for, I guess, that F, regulated energy consumption. Now, I've never been one for megajoules per meter squared per hour. I don't really know why we actually use them. There's a bunch of numbers here, 80 kilojoules for class 6, class 5, 7B, etc. We got a value of 43 kilojoules per meter squared per hour. What's the interpretation of that, guys? I struggle to see how that actually flows into what we do. So if we are building a JV3 energy model, are we really going, Jesus, hope that meets the... Are we? We're not, are we? So I just wonder what these numbers actually practically represent. And I'm not a mechanical services engineer. So I would love to know more about these. I have sort of dug around a little bit, but haven't found anything of yet to really substantiate them. But in terms of the building classes, obviously there's lots of them that we're looking at. The orange in this presentation generally represents the bits that are in focus on each slide. And we're going all the way from class 2 to class 9C, and a mix of sort of daytime and I guess nighttime buildings. In terms of how the structure is in terms of the performance solution with the opportunity of verification DTS methods, are you guys, you've all had a look at these, got into these? I'm not going to dwell on these for too long because I just don't have the time. But there are great opportunities. Naves, of course, if you are going to kick up and go for the 5.5 star and you can meet those PMV requirements, then there's a great opportunity to use that process and avoid silly JV3 modeling when you don't need to do it. Great outcome. Who wants to model when you don't need to? Green star, very interesting. If you are registering your project, there's an opportunity to use that registration in this process for certain classes of building. There is this sort of 90% of the annual greenhouse gas emissions for the reference building needs to be, or the proposed building needs to be better than 10%, let's say. That's interesting because from a Green Star perspective, and I'm not across what's happening at the GPCA in regards to this, but we have much more onerous requirements now that will make that 10% far harder to meet. So the fact that our benchmark has gone like that now, where it was the other way around before. Now we're going, oh geez, how do we get to that? So it's a very interesting outcome. Great that they got the thermal comfort stuff in there. JB3, look, it is what it is. It is the same old game. There is some opportunity here to establish more, I guess, consistent reference building numbers, which we'll probably look at, or we will look at in a little bit. And I think, as mentioned earlier, the opportunity to offset renewables is I guess far more confirmed. For the last sort of 8 years, there's been some of the industry saying no, we won't offset our fabric with renewables, and others are saying, oh yeah, we can do it. It's fine. It's open to interpretation. Here it sets it clear that you can offset as long as the energy is produced on site. And I guess the final one of the verifications is the building envelope ceiling. Great to see this introduced. While it only meets one requirement of the performance solution, it's still a value add. Difficult to see how contractually how this will work there, how people will design, and if they don't meet these performance requirements, what happens? I don't think that should deter us. I think our industry is going towards tightening up buildings because it's a great outcome for many things, not just energy efficiency. And the targets themselves, depending on the type of facade systems that you're looking at, are not particularly onerous. They're being met in Melbourne, no problem at all. Like these are not a problem. It's just I guess the contractual side of things, how that works. So very interesting stuff. In terms of the DTS methods, there's loads of stuff there. I'm not going to go into all of it. We're going to focus on the building fabric and the walls and glazing. So I'm just going to take a little sip of water. 13 minutes. Okay. So total system U values. Who's familiar with total system U values? Sorry for the people on the webinar. There's people putting their hands up. Yeah, that's probably good. Probably about 50, 60%. So system U values, we're taking into account the frame and the glazing. And it's an area that, fortunately or not, I've been exposed to quite heavily over the years because my work at a facade engineering company. Things are changing though in regards to this, and they are importantly choosing to include the wall within the system. So previously it was literally, a bit of glazing, a frame, bit of glass. Now they're doing the frame, the glass, but also the opaque area. So combining them all into one in order to establish a value that represents both. In this case is for Melbourne only, I would say. I've aimed to simplify this because we'd be looking at too many numbers. So I'm just going to represent Melbourne here. So typically for class 2, class 5, 6, 7, 8, 9B, 9A, a value of 2 is the target, okay? For others, it's 1.1 for the class 3 and class 9C. And there's a bit of a backstop there for the display glazing, but that can't be more than a value of 5.8 now. So interesting, we're combining things in terms of the combination, that bit down the bottom, the opaque bit, the spandrel bit, or spandrel or wall. It doesn't need to be a spandrel, but there are backstops there now, and you can see, we're looking at values of R1 and R2.8. R2.8 is a value that we're all quite familiar with. So if this was a wall, it was just straight through the middle of your wall. That's your R2.8. The bit now is that we've got to include that framing. So we can see an honest appraisal of what we've been doing wrong. So we've gone from R2.8, and the ABCB said, look, we need to take into account that there's this performance gap that industry has identified, and they've actually dropped that significantly down to R1. Doesn't mean R1 is actually easy to meet. R1 is not easy to meet for a spandrel. Not easy to meet at all. And it's an interesting number that I'm not 100% sure where it came from. Jess, are you across the actual origin of the R1? I didn't quite find it myself. Yeah, I believe Energy Action probably did some modeling and produced a curve, and it was generated. So that is for the vast majority of projects is going to be using the R1. If you've got where the wall is 80% or more the area of the wall glazing construction, we're looking at R2.8. So if you've only got small, tiny little windows, really R2.8. But of course, this includes thermal bridging, right? So this is a really important inclusion, and it's I guess it's setting the motions forward as to where the thinking is going in the National Construction Code, because it's not the only place that it's including thermal bridging. So whether we're thinking about window systems or wall systems, they've all got to include the associated thermal bridging now, which is great for anyone in the passive house space, because we've been thinking about this for ages. So why on earth are we not doing this? Great for people in the high performance space, but for the generic stuff, and the generic stuff, there's 3,500 permits a year or something for commercial buildings. We're looking at the top stuff. We're looking at the big stuff, the sexy stuff, the cool stuff. There's a lot of buildings out there that are just not meeting these requirements. So it's going to be a big change of speed for them to understand that if they implement it. It's a big if. So in terms of, that was the U-value side of things, the solar emittance side. So really how much solar is getting through your systems. We're talking about, we have the same structure. We've got a performance requirement of 0.13 for the class 2 to the class 9A, and then for those of the class 3 and 9C, we're at 0.07. Again, these are quite onerous targets, and what you'll find is as you go through and start to understand these, your buildings are getting dark, aesthetically getting dark. We're going back to pre-2010 here. If you walk through Melbourne and you look at dark buildings, you'll see that a lot of them were built before 2010, because that was the design response at the time. We're going to be going back that direction unless you start offsetting the areas of your glazing to account for it. So bring down your window to wall ratio, make it generate smaller values for the window to wall ratio. You'll get a flexibility from an aesthetics point of view. Again, there is a bit of a backstop for the display glazing. I won't go into that definition. That's not important. So, am I okay with the speed I'm going through this? Yes? Yeah, there's a few nods there. That's confidence. That's confidence. Good. So, in terms of how we approach this from a J1.5A perspective, we've got two options, right? We've got this single aspect, so-called single aspect. This is just taking account one elevation. Let's do your east, let's do your north, let's do your south, do your west. Incidentally, they're the only orientations we now have in the NCC. There's no other orientations anymore. Shame, isn't it? We have the same, that's for U value and for the solar admittance. Then there is a multiple aspect. So let's take into account all aspects all at once. Almost analogous to a JV3 model where we're starting to sort of do a little bit of trading. So in terms of backstops, now this is really important, and this is an interesting area where spandrels, are we all familiar with what a spandrel is? Okay, like a shadow box, curtain wall systems, a little bit of wall down the bottom, lots of frame. They perform terribly. They're awful things, really. But in terms of the approaches that the NCC are now encouraging, two key approaches. They have an approach whereby which a configuration can be chosen from a drop-down menu. Drop-down menu. I'm thinking in terms of the tool that we created, in terms of what's in the NCC. It's just a list. Configuration 1, 2, 3, or 4. Let's say configuration 1 is, typical bog standards, not broken, not thermally broken. Configuration 4 is super cool, all good. Probably 0.01% of the market. It's very, very small. You can choose one of these configurations based on the description. So over here, I've just put in one example for B, okay? So on the right-hand side of the screen, you can see configuration 2 consists of a thermally unbroken bridge frame, not too sure about the naming convention, a center of spandrel panel consisting of a double glazed opaque face, 50 air gap, and 3 mil aluminium. So no real performance there, no specification there, just a description of a configuration. What does it equal? How do you justify actually using that configuration? I don't know. But what's interesting is that we've got this backstop performance requirement of 1. Okay, 1. So what do you note on that table on the left? table on the left, configuration 1 and 2. Notice how these are lower than 1. You know what that means? You can't use any of them. You cannot use any of those in any of your designs. So it's an interesting thing. Yes, Dave, that does exist. So it's a where it comes from. I understand where it comes from, but the process was moving at a speed where it couldn't be stopped getting in. Okay, let's put it that way. So you either go that direction, right, or you can look at modeling a configuration. So pulling together, doing your therm analysis, looking at the actual configuration, and generating the value yourself. I strongly suggest you do that because it's not gonna improve these values. I would say, Jess, what do you think? 0.65, 0.7, 0.8. Like you're really not gonna get much more than that unless you're thermally breaking. The good thing is, because we're going to be thermally breaking the vision area, it's going to continue down into the spandrel area. So we will, by virtue, be thermally breaking far more spandrels in the future, which will mean these numbers are far more achievable. So, example 1. So just a bit of a random example. Class 5 office here in Melbourne, floor plate 2,000 meters squared, 8 floors. Glazing to facade ratio 70%. There to represent today's building, right? There's no shortage of these around town. Probably they're probably much bigger than this, but you get the picture. It's a fixed curtain wall system. Standard IGUs and frames. System U value of around 3.5. It's not a good performing system, but it's very, very typical. We looked at this for years. Very, very typical. And a spandrel value of R0.7. So you can see the spandrel value isn't even meeting that R1, but that's me just driving home a point. When it comes to the results, so on the left-hand side now, you've got a wall glazing U value, and on the right-hand side, you've got the solar admittance. And both of those graphs are for method 1. Running along the bottom axis, you have the window to wall ratio, and that represents the upper end, 60–70% is probably what we're aiming for. The blue lines represent our targets. Those are our DTS standards. They're what we're trying to surpass. So you can see straight away that this method 1 for this office, 70% window to wall ratio, standard glazing configurations, it's on the U value side of it is very much above that blue line. So the orange is above the blue line from 40%, meaning that 40% window to wall ratio would not even be achievable through this route. Of course, you can always go the verification pathway, right? That's what it's there, probably arguably to encourage. So I would say that that's really its main purpose. Solar admittance, I forget what did I put in here for this? 0.28. So fairly, getting fairly dark in terms of the glazing itself, and a bit more lenience there. So you can see 50%. You're okay, but you haven't got a performance. You haven't got a solution here for a design in any way or form. From a method 2 perspective, we can see that where we're using an AC energy target, slightly different approach, but ultimately we have a similar sort of scenario where, look, I mean, you could argue 50–55%, which isn't bad. I mean, 50–55% isn't bad for a bad amount of glazing. I think it's suitable. I think we should be really thinking about putting a lot less glass in buildings because there's far too much glass. But it provides a decent solution, and you can see what the game is here. It's reduce your window to wall ratio, and you've got solutions. Now, I thought I'd throw up the JV3 verification, I guess, curve here as well. And that curve on the right is just there to say, okay, let's say you drop your DTS pathway and you start going, I'm going to get smart, I'm going to do this reference building, and you want to try and surpass at, say, 70%. Have a look at the numbers. Like the orange curve shows the lowest U value at 0.22. The blue curve shows the lowest solar heat gain coefficient 0.22. The blue curve shows the the best performing U-value system at 2.43. So you're still struggling. You're not going to surpass these if you've got a solar heat gain coefficient of 0.28 and you've got a system U-value of 3.5, whatever it is. That's not the game. You're not going to get a solution out of this just through the verification pathway. So it's a headshot, but it's not definitely going to be the solution. I'll throw up an example now of how we can sort of optimize this a wee bit. What I've done, I've improved the curtain wall system, so we now have a system U-value of 2.4 involved. Upped the spandrel performance to 1.1 and put in 400 mil of horizontal shading. Now, the shading there is an interesting one because really, today we probably put shading in spandrels if we can to avoid the thermal bridging. We can't do that anymore because we have to take account for the thermal bridging. For all intents and purposes, that's magical horizontal shading. So that's actually been supporting itself, levitating in the air because it's not included in that 2.4 system calc. But as we go through it, we see the method 1, method 2 again. U values, not bad. You're probably sneaking a 60% down through the method 1 in both cases. And for the method 2, you're about 60% too. So the crux is, go hardcore on your facade, you could actually be at a 60% window to wall ratio with great solutions. Again, just a repetition of the JB3 verification. It's still by default not the solution that you want to trade off with that 70% if you want to kick that. So 50-60%, that's really what you're looking at. I have no problem recommending a little bit less, but property developers probably shoot you. We're going to have to adopt thermally broken frames. There's no question. High performance glazing, absolutely. Spectrally selective glazing. This is an interesting one because it's where you're trying to bring in as much daylight as possible, but reduce solar heat gain coefficient. Your procurement options go down to nothing. So a magical number is 0.25. Once you get to 0.25, in terms of Australian suppliers, 5 products. An interesting point of view there in terms of supporting the Australian industry. Bum bum. Anyway, 8-15%, I'd throw that at the cost of a facade. At the moment, depends on the size of the building. A facade could be 30%. Add 8-15% onto your 30%, and you start to get a feel for what the shape is of things to come. So that's one. I'll flash through another one, and then I'll get. Actually, no. What I won't because I don't want to spend any more time. It's an important one, the aged care, but I don't have the time. So, any questions at this point? I'm about 30 minutes in. That's fine. Everyone's digested as well. So, the important bit is not the tool really for this audience. I think it's the concepts behind the tool. Really where we got to. I mean, I'll go through the tool, but the idea is that we've pulled together a bunch of worksheets. It's in Excel. The worksheets enable, I guess, obviously the calculations to be linked, of course, but it's sort of centralized by this sort of user library. And I really want to sort of make a point of that. The user library is quite important to this because it's where you're going to be adding your materials and sourcing your performance from. So exercising, a rigorous control over the user libraries is a good thing. But fundamentally, those are the steps that you go through. General information, fire it in, building class, building location, building information, etc. Glazing system, nominate a glazing system, sort of, I guess, pull it together in terms of what it is. Is it an IGU? What type of framing has it got, etc. We'll apply a value to it. Wall systems, again, you're nominating a unique reference to a wall system, pulling it together, providing it for use later in the process. Shading systems are the same. So really, glazing systems, shading, wall systems, shading systems are just ways to collect specifications. That's all they are. Once you get into the wall glazing area and results, really you're just pulling those together and adding areas to them. That's it. So it's quite a linear process, really, and then you get an opportunity to produce a report. From that, not much take home. Excel, Visual Basics. Jess's machine keeps converting some of my pop-ups into Japanese, which I'm still questioning how that actually happens. We haven't quite got to the bottom of that, and that's a true story. When we were doing a test to the market, we distributed a .xlsm and a .exe. We wanted to check the response from the market in terms of a .exe. So just it's more secure, it's easier to manage. Didn't really get any strong response, yay or nay on it. How many people saw the trial version? Only probably Vince. What do you think? I mean, .exe, is it good or bad? So .exe is just obviously it's just a downloadable, pop it up, install it, etc. It's just a more stable platform to distribute. Again, in terms of the worksheets, that's how they go. You work through a workflow that accumulates information and produces a report. Okay. One big difference is navigation in the tool. The navigation is undertaken by a dedicated navigation ribbon. If you open this tool, it will kill every other control you have in Excel. Okay, so it's going to kill everything. It also sends me emails of everything. It doesn't. That was a joke I shared earlier. It doesn't do that. ABCB, it doesn't do that. Okay. So it allows you to navigate through, and what's important is that I guess the worksheet navigation, you just click through those as you would normally. The clear data, it allows you a way to either clear all the data or clear sheets at a time. And there's just some basic sort of Zoom functions there with a few tricky little things in relation to Zoom and VBAs and all sorts of stuff, but they're resolved now. The tabs at the bottom, I believe at this point in time, are gone. So I left it open. There were tabs at the bottom, the ribbon at the top. I believe the tabs are completely gone too. So you can only navigate through the ribbon. So that's probably going to annoy a few engineers, isn't it, Paul? Look at him. Paul's looking at me. So back to the user library, very important. You got your defaults. Defaults are products that have been thrown in there that represent applicable products for the market, stuff that you can use straight away, get going on the tool, apply it, and are useful enough for just for general use. But really, the onus is on the user to define their own values and their own materials. So define a product, throw in the R value, conductivity normally of the product, and then you can call that product up later. So it's important that people take that on, because that is going to be, I guess, that's really going to be the bit that builds out as you use the tool more and more. And there is a bit more of a close-up of that. Just to run by, what you can see is class types, general, more material, frame types, system types, wall types, those standard rules, the NCC, and some thermal bridging values. So all of these are just examples, but it's expected that you're going to build this out yourself. So in terms of that general approach of putting in project-specific information, it's got what you'd expect to have in a name, company, the building state, climate, building classification, climate zone, those types of things. All they do in the tool is obviously create defaults for the calculations to be assessed against. Glazing systems. Now, probably a bit more explanation here. So as you put in, the orange boxes are generally drop downs, and the white are just boxes that you enter information. So for each reference, whether it's a glazing reference or wall reference or shading reference, you've got to put in unique identifiers for each row. Once you put those in, if you do double up, it's going to tell you, hey, it's not unique. Go back, try again. Then you can then go on to choose the system type. So in this case, system type might be a curtain wall or fixed glazing or an awning system or something like that. You can then go on to add your glass and frame. So when you're doing this, you can drop it into you use your library, put it into your library, and call it back up. Methodology, interesting one. This is to do with how you approach the calculation of the glazing system itself. Now, there is a system out there called WERS. It's highly unsuitable for commercial buildings. I tend to think that no one should be using WERS at all. It's an archaic system. But AFRC is an opportunity to really use some of the calculation methodologies behind the WERS system in order to generate more meaningful values. I say it's archaic is because the WERS system uses generic module sizes. You should not use generic module sizes if you're building something that is only 300 mil wide, 600 mil wide. The ratio of frame increased drastically. The performance gets worse very, very quickly. So as we build buildings, we should be using values that represent the building, not values that don't represent the building. In terms of the total system U values, these are added into the tool. Now, there was obviously talk about generating these values based on some of the information that the user describes, but because of the process in order to do that it's such a vast piece of work, it just couldn't be included in this. But we do provide some, I guess, limitations in terms of low U values and high U values, system U values, so to guide the users to make sure that they're on track. Also, there is some functions in there that if you do start having a system U value very close to your center pane U value, it's going to start saying, hey, are you a miracle worker here? Where's your frames gone? So it's going to tell you that there's something wrong in the calc because it identifies that the difference between the two isn't enough. And then you include your total system solar heat gain coefficient in the glazing system. So that's that. In terms of the wall systems, again, a similar scenario where you're identifying a unique value. You get your wall 101, whatever it is, and then you start identifying drop downs. So as per the J1.5 requirements, you're going to have walls. They're either going to be spandrel or they're going to be traditional walls. So you identify that, and then these are sort of dynamic drop downs. So if you select something here, so select spandrel under wall type, then under wall construction you get your generic configurations, and then if you select, I think what's the nomination? Creative, wasn't it? Or just very said, she's not going to be what I'm looking for. And then it allows you to then, I guess, pull up a wall system that you may have created, which I'll go into in a second. The thickness of the wall system isn't actually used for anything. It's just used to, it's used in the reporting function, but that's it. It's not used for anything else. And then the solar absorbance. If you're using a spandrel system, just go ahead, throw your solar heat gain coefficient in there. That's fine. If you're using a wall system, go to your supplier, see what they can give you in terms of what that represents. So that's fairly easy. This is where we start to get into some new information. So you have your wall systems, and if you're going to use a spandrel, fine. But if you're going to use a more traditional wall system, whether it's a sort of a bricked, drained cavity, insulation, timber frame, plasterboard on the inside, that type of thing, you're going to want to use this calculation because this calculation, the total system R value calculator, allows the understanding of how those frames are going to impact the performance of your wall system. So what you do, you literally go through, sorry for the people on the webinar, but you fill out your layers in your nominated wall construction. You add in your thicknesses, and if you have a framing material, then you add that in your thermal line. Okay, so that thermal line, let's say that you've got some glass wall somewhere, fire in either a bit of timber or some steel, and then you're going to have to start working through what the diameters of those systems are and how those systems will impact the overall performance of a wall system. These are in line with NCC 4214, and the sensitivity of steel is really very, very sensitive. You'll find that there's a couple of important values relating to that. There is the web thickness, so the thickness of the actual C-section, in this example. So that's going to be between 0.55 and maybe 1.2, depends on where you are in Australia. If you're in a cyclone area, it might be a little bit thicker or something like that. In terms of the width is going to be pretty much 35, 40 mil, fairly standard, but it's not going to be absolutely standard. That width is going to be the same for a stud. Generally, studs normally come at 35 by 90 mil. But overall, these have quite drastic impacts on the calculation. And if you were looking at a system, let's say had a efficient 2016 R value of 2.6, throw in that steel, your system is not meeting the R1 backstop. So steel will break that system, and it won't allow it to meet the backstop. So that's a big change for our industry. Commercial buildings using lots of steel, hospitals, those types of things. They'll be interesting to see how they manage that. That's not to say there's no way for steel not to be used. There is. We can use thermal breaks. So there is a second level to this calculation. It's from this orange line here. And this is where you say, okay, I've got a steel frame here. It's in my glass wall. What can I use to break that steel? So you can nominate a product. At the moment, we can nominate EPS, but EPS is combustible. So we can't nominate EPS, but that is really our only option at the moment. So we're in this there is a dilemma out there, because how we actually treat it is going to need to be outside of combustible products. So obviously there's always ways around these things, but that is the way things are at the moment. You nominate the thickness. If there's any overlap between that 35 mil and the actual sort of the break itself, and then you add it in there, and through that, then you're back up at, let's say, a 2.6 down to 0.9, we're back up at 1.6, something like that. I'm playing with numbers here, but that's the gist of it, right? So that is an important introduction. And then once you build your system, once you build your system, little button here, Priya made me put this into the tool, where you click it and it goes to the user library. Okay, so you just have to click that button, it goes there, and then in the drop-down menu back here, you can then suddenly grab that and use that in your calculation. So it makes a lot more sense. Yeah, okay. Was that a complaint? That's okay. Shading systems. So shading systems, again, we're talking unique references, fire it in, and then there's nothing new here, guys, I'm afraid. It's horizontal, or it's the magic device. 80% of your summer solar radiation is reduced. So there is no change. We'd love to see vertical shading in there, and for it just to be a little bit more responsive from a design point of view. But there just wasn't any scope for that. But of course, you can go off and justify your own things and rebuild this calculator. Future. So I don't think there's anything new here for most people. You're nominating your P's, your G's, your H's, throwing it in as we've done for years and years, and utilize those. It will have a big impact, though, I would say, from an overall performance point of view. Solar is quite a big one, so it's going to allow, if you add shading on there, your solar heat gain coefficient that may have been down at 0.25 has probably gone back up 2.83, so you've got flexibility there. And you've also got better access to daylight, which is a bit of a trade-off. So it just depends on how you're going to put those magical shading devices onto the building if they're not in your system U-value calculation. There's some buildings will be able to do it, aged care facilities, they'll be able to do it, but big buildings with lots of glass may struggle. Okay, last bit. So as we've gone through a process, hopefully I've made some effort to relay this to you, that specifications, you build them up, you put them through, you've collected a bunch of systems based on unique identifiers for your project. This last step is really just identifying those unique identifiers for your glazing, for your shading, for your wall, putting an area against them, for the only orientations that now exist: north, east, south, and west. So it's as simple as that. The last step, you will find. I'm not going to walk over. You will find a summary up the top, where what you can't see is, I guess, the blue line is what you want to be below. The green and the red go a compliant solution and a non-compliant solution. So sometimes you might find that, you get a compliant solution, but the backstop hasn't been met. So remember, if you get a compliant solution and the backstop hasn't been met, you haven't got a compliant solution, right? That's the game. So once you collate those, you pull them together. You can use the height and width to generate the glazing area, or just override it and just use the glazing area. Fire it in. You can expand everything. So you can put in, I think it was about 16 different references for each orientation in the end. So this is expandable. You're never going to need that. You'll start to go down a route of doing area weighting and being practical about what goes into this. And then the final step is really the establishment of a reference building for the first time. So this is where we traditionally have played with to make the building as bad as humanly possible in order to get it over the line by trading it off in the magical JV3 approach. So this allows an establishment of far more consistent but much more onerous values from a JV3 perspective. So really all it's saying is that you have a minimum performance requirement. If you've got X percentage of window-to-wall ratio, it's going to nominate it for you. And you'll find that there's definitely a lot of work to be done to understand where the JV3 is going to be of value from what I can see at the moment. I'm not 100% sure. I'm sure if people start putting solar onto their buildings, that's going to assist and using that energy. But it's not the game that we have today. The game's changed. It's just how sensitive it is. So the work that's been done in this regard, I think, is pretty good. And it might be the game with JV3. It might be actually, using it to get a better architectural outcome. Let's say you go to 55% window-to-wall ratio, put back that glazing back up a little bit higher, get more procurement options. Aesthetically, you've got better solutions. Bring that through the process. But it's good that it's in there. There is one measure that needs to be adopted is just identifying whether the same shading as the proposed has been used, or if it's excluded, in order to, I guess, appraise the benefits of geometric shading on the building. So it either needs to be additional or not. But besides from that, you go through, click a button, a report comes up. The report is deemed to be suitable to many practitioners, building surveyors maybe. It will give you a summary of everything that's gone in, really, and give you an idea of, I guess, where the project's at and where you can take it. I'd probably suggest that you play around with this areas tab mostly, and maybe put in multiple systems, multiple unique references for glazing and wall systems, and just work out really what your options are there. Look, we sort of hope it's of benefit. As Morpheus said, you're going to have to choose one. It's up to you. DTS, deemed to satisfy or deemed to dissatisfy. Verification pathway, who knows? Hopefully I won't be doing it, but I'll leave that to you. I'm out. Done.